नमस्कार विद्यार्थी मित्र, कॉम्पिटिटिव्ह विभाग पोटेन्शियल टू अचीव सक्सेस या यूट्यूब चॅनलमध्ये मी सचिन पटेल आपल्या सर्वांचं स्वागत करतो. MPSC आणि UPSC मध्ये मॅथ्स ऑप्शनल सब्जेक्ट आपण जर विचारात घेतला तर तो आपल्याला पैकीच्या पैकी मार्क मिळवून देण्यासाठी उपयोगात येऊ शकतो. आणि त्याच्यामध्ये आपण मोस्टली जर विचारात घेतलं तर पेपर 1 आणि पेपर 2 असे बघायला मिळतात. पेपर 1 मध्ये आपल्याला ऑर्डिनरी डिफरन्शियल इक्वेशन हा एक टॉपिक बघायला मिळतो. ऑर्डिनरी डिफरन्शियल इक्वेशन हा टॉपिक जर विचारात घेतला तर तो 40 ते 50 मार्काचे क्वेश्चन कॅरी करतो. सो इट इज हॅव्हिंग अ 20 to 25% weightage inside the paper number 1 of mathematics as an option for MPSC and UPSC. In previous lecture we see that what is the linear ordinary differential equation with a constant coefficient, and this is your nth order linear ordinary differential equation with constant coefficient, where a0, a1, a2, an minus 1, an are the constant, where a0 is not equal to 0, and q of x, when q of x is putting as 0, then it becomes a homogeneous equation, and this homogeneous equation having the general solution, this general solution is called as a complementary equation. So in this lecture we are going with a complementary function. We are just going with a complementary function. Complementary function is there. Okay, so complementary function, first of all we use some notations for solving this equation by using a homogeneous equation is there, by putting q of x is equal to 0 and convert it into the homogeneous equation, and we use d is equal to d dx is there. Then d square, it is equal to d2 divided by dx square. D cube is equal to d3 divided by dx cube, and so on up to dn is there. Dn is equal to dn divided by dx raised to n is there. Okay, and replacing those we get the equation of this one, homogeneous equation as here a0 d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus and so on up to plus an minus 1 d plus an, and then you will use y here and it is equal to 0. Okay, and this is your what you can say homogeneous equation is in the form of this notation. Okay, and right now we are going to find out the complementary function. To solve this, we replace d by m is there. To solve this equation, replace d by m, and then you get a0 m raised to n plus a1 m raised to n minus 1 plus a2 m raised to n minus 2 plus and so on up to plus an minus 1 m plus an is there. Okay, an is there, and it is equal to 0. That is equal to 0, and this is a auxiliary equation. This is called auxiliary equation in m. Auxiliary equation in m is there, and this equation having a m number of what you can say, this auxiliary equation having m1, just a moment, I'm just going with it, m1, m2, m3 and so on up to mn be the roots of this auxiliary equation. Auxiliary equation is there. Okay, and those are the auxiliary equation, and it is having some cases related with it, and according to that cases we can find out the what you can say complementary function related with it. And case number one is there. Case number one. Okay, what is the case number one? Related to consider all those m1, m2, m3 and so on up to mn are the real and different roots. First thing is what? Let m1, m2, m3 and so on up to mn are real and different. म्हणजे काय तर सगळे रूट्स हे कसे असले पाहिजेत? रियल आणि वेगवेगळे असले पाहिजेत. At that time you will get the complementary function cf is equal to c1 e raised to m1x plus c2 e raised to m2x plus and so on up to plus cn e raised to mnx is there. And this is your complementary function related with the case 1. Case 1 is what? All the roots which are real and different from each other. At that time you will get the complementary function is equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x plus and so on up to cn e raised to mnx is there. Okay, suppose some roots are same. Let m1, m2, m3 and so on up to mr. That means r is less than n is here. Then cf having some different form is there, and which is nothing but a c1 plus c2x plus c3x square plus and so on up to c what I can say cr x raised to 1 r plus 1 is there. Okay, cr r plus 1 sorry cr minus 1 is there into into what I can get, just a moment. Yes, okay, it is equal to m, and therefore e raised to mx plus, then we are going with the cr plus 1 e raised to mr plus 1 into x plus and so on up to c n e raised to mn x is there. Okay, when some roots are same, that means m1, m2, m3 and so on up to mr is equal to same, that means it is a m, then we are going with this complementary function is there. We particularly go through with the just two roots are same. Let m1 is equal to m2 is equal to m, then cf is equal to c1 plus c2x e raised to mx plus c3 e raised to m3x plus and so on up to plus cn m raised e raised to mn x is there. Okay, this is a case number 1. Case number 1 is what? Which is related with the roots of auxiliary equation in the form of m, having n roots, and those n roots m1, m2, m3 and so on up to mn be the roots of auxiliary equation, and those are the real and different. Then we get complementary function is equal to c1 e raised to m1x, c2 e raised to m2x plus and so on up to cn e raised to mn x is there. Let r roots are same. R roots are the same. That means m1 is equal to m2 is equal to m3 and so on up to mr is equal to m. R is less than n. Then we get the complementary function is equal to c1 plus c2x plus c3x square plus and so on up to cr x raised to m r minus 1 is there, and e raised to mx plus then cr plus 1 e raised to mr plus 1 x plus and so on up to you will get the cn e raised to mn into x is there. We are going with a particular condition which is nothing but two roots are same. That means m1 is equal to m2 is equal to m. Then we get the complementary function is equal to c1 plus c2x e raised to mx plus and so on plus c3 e raised to m3x plus and so on up to you will get the cn e raised to mnx is there. Okay, this is your case number uh, one is there. We are going with the relations between the roots of auxiliary equation m1 m2 and so on up to mn is there. We just go through the case number 3 4 and so on is here. Okay, we are go through with the case number second, and just to go with the case number second is here. What is the case number second? If two roots are complex, that means later to consider m1 is equal to alpha plus beta I and m2 is equal to alpha minus beta I. Okay, these two roots are complex and other roots are real and distinct, that means different. Then the solution, then complementary function is equal to here you get alpha m1 is equal to alpha plus beta I, m2 is equal to alpha minus beta I. जर याच्यामध्ये अशा पद्धतीचे रूट्स असतील तर कॉम्प्लिमेंटरी फंक्शन that means yc, and this yc is given as e raised to alpha x inside the bracket c1 cos beta x plus c2 sin beta x plus these two roots are c1 and c2 is there, then c3 e raised to m3x plus and so on up to plus cn e raised to mn x is there. Okay, this is your complementary function. That means complementary function yc is equal to e raised to alpha into bracket c1 cos beta x plus c2 sin beta x, c2 sin beta x plus and so on up to c3 e raised to mx plus and so on up to cn e raised to mnx is there. Okay, what does it mean here? When two roots are complex root, then we just c1 cos beta x plus c2 cos sin beta x, and it is a multiply by e raised to alpha x is there. Then all other roots are real and distinct. So just say skip these two roots c1 and c2, then go through c3 c4 c up to cn as it is in the case number 1 is there. Okay, this is your case number 2. Then case number 3 is that case number 3 is here. If m1 is equal to m2 is equal to alpha plus beta I, alpha plus beta I, and m3 is equal to m4 is equal to alpha minus beta I, that means what? These are the two roots, four roots are complex and all other roots are real and different. All other roots are real and distinct is there. Okay, in this case in this case, say complementary function yc is written as e raised to alpha x inside the bracket c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x plus plus c5 e raised to m5x plus c6 e raised to m6x plus and so on up to plus cn e raised to mnx is there. And these are the cases related with the uh, complementary function which is obtained from homogeneous equation by putting q is equal to 0 in linear uh, ordinary differential equation of nth order with a constant coefficient is there. Here, by replacing the d by m, you will get the auxiliary equation in m, which is having a n number of roots. That means m1, m2, m3, and so on up to mn. This is the roots of the auxiliary equation. Then we are go through case number 1, case number 2, and case number 3 is there. Later to consider m1, m2, m3, and so on up to mn. All roots are real and distinct. Then complementary function yc is equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 m raised to e raised to m3x and so on up to cn e raised to mnx is there. When some roots are common or some roots are same, that means later to consider our roots are same. That means m1 is equal to m2 is equal to m3 and so on up to mr is equal to m. R is less than n. That means a count of same roots which is less than the nth order of the differential equation. Then we get the complementary function is equal to c1 plus c2x plus c3x square plus c4x raised to 3 and so on up to cr x raised to r minus 1 into e raised to m plus cr plus 1 e raised to mr plus 1 x plus and so on up to cn e raised to n mn x is there. And then we go through a particular condition where only two roots, that means m1 and m2 is equal to m, that means two roots are same. Then we get the complementary function is equal to c1 c2x e raised to mx plus c3 e raised to m3x plus c4 e raised to m4x plus and so on up to cn e raised to mnx is there. In case number second, two roots are complex. That means first root is m1 is equal to alpha plus beta I, m2 is equal to alpha minus beta I, and other roots are real and distinct. That means different. Then complementary function is equal to yc is equal to e raised to alpha x c1 cos beta x plus c2 sin beta x in plus c3 e raised to m3x plus and so on up to cn e raised to mnx is there. Case number 3 is what? Here two roots are m1 and m2 is equal to alpha plus beta I, and m3 and m4 is equal to alpha minus beta I, and all other roots are real and distinct. Then complementary function yc is equal to e raised to alpha x c1 plus c2x cos beta x plus c3 plus c4x sin beta x and plus c5 e raised to mx m5x plus c6 e raised to m6x plus and so on up to cn e raised to mnx is there. These are the cases related with the complementary function of homogeneous equation obtained from the linear ordinary differential equation of nth order, and we get those three cases related with the complementary function. We are going with a particular solution or particular integral related with that uh, general form of nth order ordinary differential equation with a constant coefficient, and then we get the general solution of that linear ordinary differential equation of nth order in the form of y is equal to yc plus yp is there. We are just to go through that cases, case 1, case 2, case 3 for the finding out the complementary function, that means yc only. Then we are going with a particular integral or particular solution related with a related with a general form of nth order ordinary differential equation with a constant coefficient is there. हे तुम्हाला समजलं असेल तर व्हिडिओला लाईक करा, शेअर करा आणि सबस्क्राईब करायला विसरू नका. थँक्यू.